if we consider what was the applied potential or else applied current. Okay. So if we consider voltage versus current, right? We are applying some current, external electricity to the system. The potential will be varying. That may be either towards oxidation side or towards reduction side. So if we consider this one, this may give like this type of right. So this is the highest current is the limiting current. The highest current is the limiting current. This lowest current is the residual current. Lowest current is the residual current. The difference between these two, okay, the difference between this limiting current and residual current is known as diffusion current, that is denoted with ID. ID is the diffusion current. Okay, right. So coming part, I'm going to share, right? Is it visible to you? Yes. Esma, is it visible to you?
Yes, sir.
Visible, sir.
Yes, yes. Okay. Coming to the part of yesterday's class, a little bit briefly, then continue with our today's class. LGT completed. Okay. Here we are. Okay. Right. Determination of pH from EMF measurements. Okay. Yesterday's. So this is the electrolyte solution. Whose electrolyte solution pH we want to determine? We have to dip the hydrogen electrode in that. Simply dip the hydrogen electrode into the electrolyte solution whose pH can be measured. Okay, right. Once the hydrogen electrode is dipped, it will undergo oxidation, right? If that hydrogen electrode is acts as anode, at anode oxidation will be takes place. That is half of H2 gas is gives rise to H plus electron. Right? So then now applied the Nernst equation. E of H2 is equals to E naught of H2 minus RT by F ln of H plus. This RT by F ln H plus because E naught of H2 is 0. Therefore, this can be written as minus 2.303 RT by log of H plus. But this log of H plus is known as pH. This is E of H2 is equals to 0.059 pH. So here we'll get one pH equation, that is the pH is equals to E of H2 by 0.059. Okay, right. So now if we know the E of H2, that is reduction potential of hydrogen electrode, we'll get the pH of the solution. For this, what we should do, this hydrogen electrode is coupled with the calomel electrode. This is the calomel electrode. So once the electrodes are coupled with each other, that may produces so E cell. How we are getting the E cell, that we will see. Right. Ah, yes. So this is the connectivity, right? This is the hydrogen electrode whose solution we want to determine pH, right? So, and this is the caramel electrode. These two are coupled with potentiometer and as well as with the salt bridge. So once the experimental setup is completed, you'll get this equation, that is E cell is equals to E of standard caramel electrode minus E of H2. So from this, E of H2 is equals to E standard caramel electrode minus E cell. This is the E cell which is obtained from the instrument, that is the pH meter, potentiometer. Then E of standard caramel electrode is the reference one, right? That is 0.242. By the substitution of these two, we can get the pH. We can get the pH, right? So this is the pH of the electrolyte solution, right? So E standard caramel electrode, E standard caramel electrode, that is 0.0242. E cell which is obtained from the potentiometer and divided with 0.059. Okay. So that will give the pH of an electrolyte solution. What was the problem here? Means the handling of hydrogen gas. Hydrogen is the gas only. The handling of that hydrogen gas is too difficult. Instead of instead of that hydrogen gas, we have to use some other electrodes that are like pin hydrogen electrode and glass electrode. Yeah, pin hydrogen electrode and glass electrode. Hydrogen electrode was gas. The handling or utilization of that hydrogen electrode is too difficult, right? It is very difficult to get EMF of hydrogen gas electrode. Instead of instead of these, or in place of this hydrogen electrode, we have to use some other electrodes like subsidiary electrodes or secondary type of electrodes. What are the secondary type of electrodes means? One of the electrode is the twin hydrogen electrode. One of the electrode is the twin hydrogen electrode. Right, right. Hydrogen electrode. Am I audible? Yes, am I audible?
Yes, sir.
Okay,
Yes, sir.
okay, fine. Hydrogen is the equimolar ratio of quinone and hydroquinone. This is the structure of the quinone, that is benzene double bond, here double bond O and here below double bond O. Then OH will be there, that is the hydroquinone. The ratio of quinone and hydroquinone is nothing but quinhydrone. Once the quinone is undergo absorption of two hydrogen plus and two electrons, which will be converted to the quinhydrone. The quinone itself may undergo what? Hydroquinone. Quinone will be converted to the hydroquinone. Okay. This is the hydroquinone. This is the quinone. Here, gaining of electrons, that means the process is called reduction process. The process is called what? Reduction process. Okay. Right. Okay. Now, right. This is the equation, right? So Q of 2H plus 2 electrons gives rise to QH2. Right. Here I am doing one thing. This pointer will be erased spontaneously, right? You have to see where the pointer is there, right? So this is the Q plus 2H plus 2 electrons gives rise to QH2. Means quinone is converted to the hydroquinone. So then now applying the Nernst equation, E cell is equals to E naught cell minus 2.303 means minus RT by NF ln activity of the product by activity of the reactants. The activity of the products means this one. The activity of the reactants means Q and H2. These are the activity of the reactants. This is the activity of the product. Okay. Right. So, but the QH2 is the solid one and Q is the solid one. Both are solids. Therefore, the concentration for solids is equals to 1. So, therefore, ln of this one means ln1 that is equals to 0. That is equals to 0. Therefore, that value will be substituted. EQ is equals to E naught Q minus 2 RT by TF ln of QH by Q minus RT by F ln of H plus. Means in this above equation, this will be written one part and this 1 by H plus square will be written another part. This is another part. Okay. So then for simplifying, we'll get finally EQ is equals to E naught of Q minus 0.0591 pH. Means as we utilize the hydrogen gas electrode, we can get the pH of electrolyte solution. Instead of that hydrogen gas electrode, we have to utilize this twin hydrogen electrode. This twin hydrogen electrode also gives the pH of an electrolyte solution. That's why instead of hydrogen electrode, we can use these subsidiary electrodes. Subsidiary electrodes. Okay. Right. So one more concept will be there. This is not discussed at yesterday. That is determination of solubility product of sparingly soluble salts from EMF measurements. Right. Sparingly soluble salts means a partial dissociation into the ions. Right. S. Naidu, tell me. S. Naidu, tell me. S. You raised the hand. Is there any reason to raise the hand? S. Naidu. Am I audible?
Yes, sir.
Yes, sir.
Okay, okay. Right. Right. Sparingly soluble salts means which will be partially converted into the ions, not completely converted into the ions. For example, silver chloride will be there. That silver chloride will be converted to the silver plus Cl minus. A very few amount of silver chloride is converted to the silver plus Cl minus, right? So then consider the cell. Cl gas is dipped in HCl solution. Then Ag by AgCl is a solid. Once we connect these, AgCl is converted to the Ag plus of Cl2, right? So see here, Ag is converted to the Ag plus Cl minus. Here Ag is converted to the Ag plus of Cl2. Therefore, from these two equations, we can written as AgCl is equilibrium with Ag plus Cl minus gives rise to Ag plus of Cl2. So means this will be in equilibrium, right? So this AgCl is converted to the Ag plus and Cl minus will be equilibrium. So further it will be converted to the directly Ag plus of Cl2. Ag plus of Cl2. Now apply the Nernst equation to this, right? For which equation means AgCl plus Cl minus gives rise to Ag plus of Cl2. For this equation, we're going to apply Nernst equation. That is E cell is equals to E naught cell minus 2 RT by F ln 1 by activity of Ag plus activity of Cl minus. Because this is a solid, activity is 1, Cl2 is the gas, activity is 1. Products activity is 1, but reactants are the ions that are the liquids, therefore that has activity. Therefore, this activity of Ag plus and Cl minus will come to the numerator. So that is, this becomes minus becomes plus. This minus becomes plus. Right. Then Ksp solubility product is the activity of Ag plus into Cl minus. This is not Ag plus plus ACl minus. This is the Ag plus into Cl minus. Okay. Here I am going to write. So K of Sp is equals to solubility product. K of Sp is equals to activity of Ag plus into activity of Cl minus. So this is the Ksp, that is the that is the solubility product, right? So therefore, instead of that, if we can substitute this, V cell is equals to E naught cell plus RT by F and Ksp. Upon substitute all those values, RT by F and E naught cell, right? And E cell, we can get the Ksp value, that is 1.078 into 10 to the power of 10. Therefore, the solubility product of sparingly soluble salts also can be determined with the help of Nernst equation. With the help of Nernst equation. So just to see, potentiometric titrations will be there. Three type of potentiometric titrations: acid-base titrations, redox, and precipitation. This already discussed yesterday. So these are the EMF curves, sigmoid curve, and peak. So the potentiometric titrations means one of the potentiometric titration is the acid-base titration. Acid-base titration. Right? This already discussed in the previous class, even in the practical sessions. Okay. Hydrogen electrode instead of gas electrode. So these are the curves, EMF curve, delta I by delta V curves. With the help of this, we can get concentration of the given unknown acid solutions. Concentration of the given unknown acid solutions. Okay. So like in a similar way, precipitation titrations will be there and redox titrations also will be there. Okay. These are the types of the electrode. Metal ion electrode. Just you have to read these all things. Metal insoluble salt anion electrode. Gas electrode. Then glass electrode. Then calomel electrode. Then standard hydrogen electrode. Then twin hydrogen electrode. Right. So you have to go through the types of the electrodes. Right. So just you have to read how many types of the electrodes will be there. What are those? How they how they construct the various type of the electrodes. Okay. ఎస్ ఆనంద్ గారు చెప్పండి.
Sir,
చెప్పండి.
uh, uh, can you forward, sir, for us?
విచ్ వన్?
The PDF, sir, the notes which you are explaining.
ఓకే.
So, how to get that, sir?
I
Is possible, please?
I already sent to the Dhananjaya, sir. You may collect from him.
Thank you, sir. Okay, I will collect.
Okay.
I'll
You
take
know na
from.
Dhananjaya, sir?
Sir also there, sir, in the class.
Yeah. So I already
Okay.
shared that one, right? You have to collect.
Thank you, sir.
Okay. Right. So just go through the various types of the electrodes, right? How the construction of electrodes will be there, right? Then how we are utilizing to get the EMF with the help of utilization of those electrodes. Right. Now see electrode polarization. Electrode polarization. Polarizability is nothing but so one becomes generally gets positive charge, the another becomes getting negative charge. Delta plus and a delta minus. So this is the becomes polarized nature. Right? Or we may call as dipole nature. One thing get positive charge, the another one get a negative charge. Right? So but in our terminology, so what is the electrode polarization? Okay. The electrode is said to be polarized when the equilibrium position is disturbed by the application of external current. That is the definition of electrode polarization. So I already explained oxidation, equilibrium with reduction plus n electrons, right? That equilibrium position will be disturbed by the application of external current. So once the equilibrium position is disturbed means whether the reaction may favored in case of towards oxidation or the reaction may be favored in case of reduction reaction, right? Okay. Yes. Right. So one more concept will be there, that is the decomposition potential. Decomposition potential, which is very important for exam point of view. Decomposition potential. Most of the time, you will get this question in the examination. Okay. Right. So what is the decomposition potential? We'll see. Simple, go through the definition. The minimum amount of voltage is required, right? The minimum amount of voltage is required. This voltage is required to produce continuous electrolysis process. What is the meaning of electrolysis process means? So the solution itself will be converted into the ions. For example, the HCl will be there, HCl. This HCl will be converted into the H plus and Cl minus. This HCl will be converted into the H plus and Cl minus. H plus and Cl minus. So this is the process is electrolysis process. The conversion of H plus and Cl minus from HCl. The how much voltage is required to produce a continuous electrolysis of an electrolyte solution. Continuous electrolysis of an electrolyte solution. by the application of external current is known as decomposition potential. Yes, sir. Is it clear the definition? The how much amount of voltage is required? How much amount of voltage is required to produce the continuous electrolysis of an electrolyte solution? The continuous electrolysis of an electrolyte solution. Right. That can be explained with the help of this simple diagram, decomposition potential. Here A is the electrolyte solution. E and E dash are the electrodes. S is the stirrer. V is the voltage. M is the milliammeter. This is the battery. Then this is the variable capacitor. See how many parameters will be there. Just okay. Right. With this variable capacitance, right? So listen carefully. Right. So just to see the diagram only, go through the diagram. So this is the variable resistance, right? Then this variable resistance, we are going to apply the potential to the system of electrode E and E dash, which are connected through the voltmeter. Okay. With the help of variable resistance, some of the potential is applied to the system of two electrodes which are connected with the voltmeter. So once the voltage is applied, the electrolysis process will be done. Right? That A is, for example, this A is considered as the HCl, which will be converted to the H plus and Cl minus. Which will be converted to the H plus and Cl minus. This will be takes place upon addition of variation of voltage. Right? So once applied voltage will be there, the electrolysis process will be done, which will be converted to the ions. This may produces electrical current. That electrical current will be measured in the milliammeter and that will be stored in the battery. As the variable resistance, right? Some different type of voltage will be applied. We'll get different current, right? We'll get different current. Different type of voltage is applied. We'll get different currents. Different currents. So therefore, right? The decomposition potential can be explained with the help of the help of the simple below diagram. So that is we'll see. Right. Initially A to B, right? As the voltage is constant as the electrical current is applied. Okay. Current versus voltage. Current versus voltage. Okay. But B to C, it will be little bit increases. But from C to D, it will be sharp increases. Where at particular current, the voltage will be in sudden jump. Voltage will be in sudden jump. That is from B to C, C to D. Right? B to C, C to D. That voltage is known as decomposition potential. Decomposition potential. Okay. Right. So decomposition potentials means upon application of external current, the sudden jump in the potential will be there. Where the sudden jump in the potential, that potential we may call as decomposition potential. Right? Decomposition potential. One more concept will be there, that is the over voltage. Over voltage. This is also important for exam point of view. That is the over voltage, right? Over voltage. As we know, we people are charging our mobile phones, right? Why gonna use adapter? Directly power we have to give to our mobile phone. What was the help of the adapter?
To control the voltage.
Yeah, it's control that, right? So here also same, if the hydrogen reduction potential is zero, standard reduction potential. When it is zero means the hydrogen will be combined with platinum wire. Hydrogen is combined with platinum wire. Other than the platinum wire, any other metal ions will be used to connection of hydrogen. So that will show some little bit of voltage. So when hydrogen is combined with the platinum, what was the voltage? Hydrogen is combined with any other element, what was the voltage? The difference between the two is called over potential. The difference between the two is called over potential. Or else go through the definition, right? Over voltage can be defined as the difference between equilibrium potential and actual potential of an electrolyte solution. So this is the equilibrium potential minus actual potential that will give over voltage. So this can be explained with the help of one electrolyte solution beautifully, right? So that we may polarize concentration over potential. So that we'll discuss later.
Yeah.
Okay. Yes.
Here, electrode of that potential equivalent potential, sir.
Equilibrium potential.
Equilibrium potential and actual potential. So
Actual potential.
how will find sir equilibrium potential?
When the connection with others, right? Just now, as I said that hydrogen is combined with platinum, that will give the actual potential. That hydrogen will be combined with other than the platinum. So that will give the equilibrium potential, right? So just see here below, consider,
Yes, yes.
right? So here consider the cell, that is platinum with hydrogen is dipped in HCl solution, then platinum with oxygen gas. Okay. The potential is required to get the overall cell reaction is what? 1.7 volts. So means we need to get this overall cell reaction with the help of these conditions. What are those? The platinum will be dipped in hydrogen gas and that will dipped in HCl solution. The same platinum will be dipped in oxygen gas. So the 1.1, 1.7 volts of potential is required to get the overall cell reaction. If this reaction should be reversed by producing H2 and O2, immediately the reaction will be reversed, right? So that means equilibrium is attained. The more than 1.7 volts of potential is required, right? So equilibrium means, for example, clearly you have to set this, right? So I may convey. This is the setup. Okay. What was the setup means? Platinum is dipped in HCH2. Means platinum is combined with hydrogen gas, which is dipped in HCl. Another platinum is dipped in oxygen gas. This is also dipped in HCl solution. So here one reaction will be takes place. That is the overall reaction from here to here, right? So this is, for example, reactants to products. Okay. This is the one reaction to takes place. How much of voltage is required means 1.7 voltage is required to get this reaction. Okay. So once this reaction will be reverse, means products are gives rise to the reactants. At that time, more than 1.7 is required. What is the this difference energy? That is called over potential. So here clearly mentioned the reaction is should be reversed to producing H2 and O2. More than 1.7 volts of potential is required. More than 1.7 volts of potential is required. Right? So that is the called over potential. Right? Is it clear? Yes. Yes. Is it clear?
Yes.
Okay. Then concentration over potential will be there. The next one will be concentration over potential. Right. So what was that concentration over potential? Okay. See what we are doing. Right. Here is the electrolyte solution. The metal rod which is dipped in electrolyte solution. Right. Right. Here is the electrolyte solution. The metal which will be dipped in electrolyte solution. Right. What is concentration over potential? Right. So electrolyte solution will be there. Just see here. This is the beaker containing electrolyte solution. The metal rod which is dipped in electrolyte solution. Right. The metal rod which is dipped in electrolyte solution. So this metal rod is acts as anode. Metal rod is acts as anode. Right. So the metal is acts as anode. At anode oxidation will be takes place. That is M is gives rise to M plus N plus N electrons. Then now apply the Nernst equation. E of M is converted to M plus N, means this is converted to the M plus N. Okay. So then E naught of M by M plus N minus RT by NF log concentration of the products means M plus N divided by concentration of the reactants means M. M is the solid, therefore its activity is equals to 1. Therefore, we will get this equation. That is the E cell is equals to E naught cell minus RT by NF ln M plus N. Right? So, as with the help of this equation, the E cell is directly proportional to concentration of Mn plus M plus N. Okay. Directly proportionality will be there. As we increase the concentration of M plus N, so the EMF also increases. the EMF also increases because of the directly proportionality. So that sentences is there here, right? So this is the overall equation. So then, so the sentences will be, right. So as the concentration of M plus N increases, the EMF of the cell also increases. This is due to increasing the concentration, means increasing the mobility of ions. So this is the concentration that is increasing the mobility of the ions. For example, this metal rod is acts as cathode. If that is acts as cathode, at cathode reduction will be takes place. M plus N is converted to the N. At that time, E cell is equals to E naught cell minus RT by F ln. Product is M and reactant is M plus N. 1 by M plus N. So this E cell is universally proportional to the M plus N concentration. That means as the M plus N concentration will be increases, the EMF will be decreases. This is the EMF. Okay. This is also EMF. This is the concentration of the M plus N. This is the concentration of the M plus N. See these two situations. In both the cases, concentration of Mn plus is increasing. But in one case, EMF is increasing. In another case, EMF is decreasing. The difference between this increasing and decreasing, that is called concentration over potential. When it is increasing, when it is decreasing, what is the difference between these two? That is called concentration over potential. Right? So I think, are you understand?
Sir,
Yes.
here selection of metal will be important, no, sir. While taking
Ah,
M, sir,
yeah, metal is converted to the metal ion, means depending on the concentration of the metal ion, sometimes EMF will be increases, sometimes EMF will be decreases. That increment and decrements, what is the difference between that two? That is called over potential.
sir,
Yes.
the same metal will be placed at anode and as well as cathode, sir.
Yeah,
Hmm.
we should, right? Means, so whenever the two metals will be there, one itself acts as anode, the other will be automatically acts as cathode, like that.
Right.
Different metals will be there whose reduction potential is more, that will undergo reduction, means acts as cathode. Less reduction potential containing electrode acts as anode, when difference will be there. Okay.
Right, sir. Right, sir.
Now, right. So this is the concept of concentration of over potential. Just go through the sentences. Finally, sentences will be there. Right. What are the sentences? Means the concentration over potential is obtained as the EMF increases or decreases. Sometimes EMF is increasing, sometimes EMF is decreasing. So there is increasing or decreasing of the EMF, that is due to the change in concentration of the ions. Change in concentration of the ions. As the concentration of the ion will be changed, therefore its mobility also change. Its mobility also change. Mobility of the ions also change. So this is called concentration over potential. Concentration over potential. Okay. Right. Some small concept will be there. The concept of activity and activity coefficients. Okay. Concept of activity and activity coefficients. Right. as we know, are mentioned in the chemical cells with transference and without transference, concentration cells with transference and without transference. There we utilizes activity and activity coefficients. The concept of activity and activity coefficients can be obtained for the electrolyte solutions which are deviating from the ideal behavior. Any electrolyte solution will be there if that is ideal solution. No need to go for the activity and activity coefficients. When it is a non-ideal solution, when it is a non-ideal solution, then only we'll go for activity and activity coefficients, right? So the non-ideal solutions means that are deviating from the ideal behavior, right? If the electrolyte solution becomes ideal, the chemical potential values can be written as mu I is equals to mu I naught plus RT ln Xi. Here Xi is the mole fraction, that is the concentration of the electrolyte solution. This is in case of ideal solutions. Case of ideal solutions. The same simple equation is applicable for the non-ideal solutions. So that we can written as mu is equals to mu naught plus RT ln AI. This is the AI is the activity. So for ideal solutions, we have to utilize the notation that is the Ki, that is the concentration. For non-ideal solutions, we have to utilize that is the concept is activity. Activity and activity coefficients. Activity of electrolyte solution is defined as the product of activity coefficients into molarity, right? So this already we know. A is equals to gamma into M. This can be applied for the chemical cells and concentration cells during with transference and without transference. Okay. Excuse me. Right. If you consider for cation, A plus is equals to gamma plus and M plus, for anion, A minus is equals to gamma minus means. So this may indicate individual ions. If it is an electrolyte solution, A plus into A minus. That is gamma plus M plus into gamma minus M minus. Therefore, we can written as A plus or minus is equals to gamma plus or minus and M plus or minus. A plus or minus is equals to gamma plus or minus and M plus or minus. This gamma plus or minus is the mean ionic activity coefficient. M plus or minus is the mean concentration. A plus or minus is the mean ionic activity. Okay. Plus or minus means both the ions are mentioned. That is the will denoted with the mean concept. Okay. So that is what A plus or minus is equals to mean activity of an electrolyte solution. Gamma plus or minus is equals to mean activity coefficient. M plus or minus is equals to mean molarity or concentration of an electrolyte solution. Concentration of an electrolyte solution. Okay. Right. Then what is the mean ionic activity coefficients that we'll see? That is gamma plus or minus. So with the help of this equation, MA is converted to the M plus plus A minus. This X and Y are the coefficients. Okay. MA is the electrolyte solution, M is the cation, and A is the anion. The equilibrium constant K is equals to M X of plus into A Y of minus by MA, or activity of M plus into activity of Y A minus divided by activity of MA. But individual ions activity already we discussed it before, right? So for positive ion, that is the A plus, okay? A plus, that is A m plus is equals to gamma plus into n plus of x. For anion, that is A of A is equals to gamma minus into m minus power y. Therefore, we can get A plus or minus is equals to, we can get A plus or minus is equals to gamma plus or minus power x plus y and m plus or minus power x plus y. Therefore, gamma plus or minus power x plus y, x and y are the coefficients. So whether one electrolyte will be there, HCl is there, so the both x and y will be only one. But so Na2SO3 will be there. This is the 1,2 electrolyte solution. Na2SO4. Na is plus 1, 2 Na plus and 1 SO4 minus 2. Or else H3PO4 will be there. H3PO4 will be there. 3 hydrogens and 3 H plus and 1 PO4 minus. Right? 1 PO4 minus 3. 1 PO4 minus 3 and 3 hydrogens H plus. So because the X plus X and Y values are becomes varying for different type of the electrodes. Therefore, the mean ionic activity coefficient of any type of the electrodes that can be get with the help of gamma power plus or minus power x plus y is equals to a plus or minus by m plus or minus power x plus y. This is gives mean ionic activity coefficient. The concept of this mean ionic activity coefficient can be explained with the help of d by Hackel equations or theory, right? D by Hackel theory will be there. So then further extended d by Hackel limiting law, extended d by Hackel limiting law. So then previous that d by Hackel limiting law will be there means what are the limitations of d by Hackel theory? D by Hackel theory, d by Hackel limiting law, extended d by Hackel limiting law, d by Hackel and Amsager, d by Hackel-Amsager equation. So these are the left topics in this black, right? So just we'll cover all these four topics in the next class. So then after that we'll enter into the next new black. Okay. Only four topics will be left: d by Heckel theory, d by Heckel limiting law, extended d by Heckel limiting law, then d by Heckel-Onsager equation. D by Heckel-Onsager equation. So these topics, remaining topics, we will discuss in the next class. Okay. Yes. Yeah, another black quantum chemistry and photochemistry will be there. So that we will start. We have another 6 classes will be there. So we have to cover those syllabus in the next further classes. Okay.
Sir,
Yes. Yes. Tell me.
sir, mean equation activity coefficient, sir. Mean
Okay.
ionic activity coefficient. Can one more time, sir?
Mean ionic means it will be represents both cation and anion at a time. That is the mean. If it explains about only cation, that is the gamma plus. If it explains about the only anion, that is the gamma minus. The both ions are explaining at a time. That is the mean concept. Okay.
Sir,
Similar to the activity is equals to activity coefficient into molarity. Same concept only. Mean means both ions should consider. Okay.
sir, sir,
Yes.
I am asking in denominator, sir, that that gamma plus minus to the power x plus y minus a
Uh,
plus minus divided by m plus
M
minus
plus or minus
power
X
x
plus
plus
Y.
y, how it comes, sir?
Before only previous equation is there. A plus or minus is equals to gamma plus or minus power X plus Y, M plus or minus X plus Y. This m will be moved to left hand side, that is will come denominator here only. So one thing we'll get, that is a gamma plus or minus of x plus y. That's it.
Okay, sir.
Okay. Right. Yeah,
Yes.
you have to join in the next class. Next class is there. Next
General
class is
chemistry.
there.
Yes, sir.
Yeah. So the
Sir,
remaining
we are
topic,
having only 4 classes.
yeah, every day 4 classes.
No, sir. We are having only 4 online classes are left.
Remaining 6.
Yes, sir. No,
Acha.
sir. 4.
Yeah. One thing we missed at the time, at the first time. So that I will
Okay,
cover
sir.
during odd days. Okay, not only Saturday,
Okay, sir.
Sundays. I may ask to the quotation officer to give the permission. Then I can cover during these odd days like Monday, Tuesday, Wednesday, Thursday, any 1 2 days. I can take those 2 classes
Okay, sir.
because huge syllabus will be there. I want the 2 classes. Okay.
Okay, sir.
Okay. Right.
Thank you, sir.
Now I am going to conclude the meeting. Right. So people may join in the next class. Okay.
Okay, sir. Thank you.
Yes, sir. Good day, sir.
Okay.
Thank you, sir.